Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking Databricks for sponsoring today's event. Databricks is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Harnessing the Power of AI with Azure Databricks, and that'll be presented by Databricks. But before we begin, I'd like to briefly review the format for today's event. We have, today's event will be an hour long. We have three presenters who I'll present and introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, Prasad Chandravihar with Lennox International, Deepsha Mengani with Microsoft, and Wayne Chan with Databricks. Now, Prasad is a leading data scientist at Lennox International. He's been with Lennox for 5 years, has worked on data science projects across a variety of domains, such as supply chain, marketing, tech support, and engineering. He currently leads the machine learning team focused on executing strategic initiatives across different verticals. Prasad has completed an executive program on artificial intelligence from MIT's Sloan School of Management and holds a bachelor's degree in computer science. Now, Deepsha is a product marketing manager for big data and advanced analytics at Microsoft. She focuses on driving the go-to-market strategy for multiple services and solutions within Microsoft's Big Data and Advanced Analytics group. Wayne is a senior product marketing manager at Databricks, responsible for go-to-market for Databricks' unified analytics platform. Wayne received both his bachelor's and MBA from the University of California at Irvine. So everyone, thanks for being with us today. We're looking forward to your presentation. Now, harnessing the power of AI on streaming data generated by thousands of IoT devices is no easy task. So in today's Data Science Central webinar, you'll learn how Lennox International leveraged Azure Databricks and PySpark to solve their biggest data challenges and improve data science and engineering productivity. So in today's webinar, we'll cover the data orchestration challenges Lennox faced with which impacted model accuracy and data processing times, how they build the data pipelines, machine learning models, and extract predictions using Azure Databricks and PySpark, and how they use the H2O driverless AI and sparkling water on Azure Databricks clusters, which can scale up to 1,000 cores. So Deepsha, with that, I'm going to turn it over to you. You can begin just as soon as you're ready to go.
Thank you. So as you already mentioned, that we're going to talk about Azure Databricks, but Azure Big Data and Advanced Analytics portfolio is bigger than just Azure Databricks. So I wanted to talk about what are the customer scenarios that we see our customers doing with Azure Databricks and with our Big Data and Advanced Analytics portfolio of Azure services. Three common scenarios that we see our customers implementing are: one, modern data warehousing. What that means is the traditional data warehousing was able to take care of structured data. Now with this big data emerging, there is a need for being able to use unstructured data, convert it into structured data, and then do analytics on top of it. And to be able to do unstructured to structured, that's where Azure Databricks comes into play. Advanced analytics. That's a scenario, for example, a customer wants to understand churn analytics, where they want to understand what regions are my customers about to churn so that I can run the right campaigns for those customers. So building sophisticated machine learning and deep learning algorithms, that is the advantage of Azure Databricks. And the third, last but not the least, stream analytics. Being able to process real-time data as well is something you can do with Azure Databricks. And how does this fit in our Azure portfolio? Let's look at the modern data warehousing scenario. Azure Data Factory is our data movement and orchestration service that allows for easy code-free data movement from over 75 data sources. You can use either Azure Blob Storage or Azure Data Lake Storage to store your structured and unstructured data into one single data lake. You can use Azure Databricks to convert your unstructured data to structured data before loading it into the extremely powerful data warehouse called Azure SQL Data Warehouse to visualize in Power BI. And this is the power of Azure to provide end-to-end solutions based on your needs. With an advanced analytics on big data, you can build customer applications on top of Azure Cosmos DB. Everything else being the same, you can use Azure Databricks to build sophisticated machine learning algorithms and load them into Azure Cosmos DB to directly serve it to your customers in applications where they are. And real-time analytics. You can use Azure Event Hub, Azure IoT Hub, or HD inside Kafka to ingest real-time and streaming and IoT and sensor data, and then use Azure Databricks to process the real-time data to then either serve it within Azure SQL Data Warehouse for your visualization needs or into Cosmos DB to serve it to your customers in the applications that they're at. But what is Azure Databricks? To be able to really understand Azure Databricks, let's take a step back to see what Spark is and why is it so important. I'm going to hand it over to Wayne to talk about Spark.
Great, thank you, Deeksha. All right, so for those of you who are not familiar with Spark, when it comes to ease of use, Spark happens to be the #1 option in terms of big data processing, far faster, easier to use, and more reliable than Hadoop. Spark offers APIs for several languages, such as Scala, Java, and Python, besides having the likes of Spark SQL. It's relatively simple to write user-defined functions. It also happens to boast an interactive model for running commands. Hadoop, on the other hand, is written in Java and has earned the reputation of being quite difficult to program, although it does have tools that assist in the process. So let's just dig into a little bit more about what Spark is. So the key of it is the fact that it's an in-memory-based technology. And this allows it to be extremely good at data processing at scale. In this technology, Spark loads all of the data into the internal memory of the system, and then unloads it onto the disk later. This way, a user can save a part of the processed data on the internal memory and leave the remaining on the disk. Spark also has an innate ability to load necessary information to its core with the help of its machine learning algorithms. This allows it to be extremely fast. So Spark's made up of several different components. At the core of it is Spark's core, which manages several different important functions like setting tasks, interactions, as well as producing input-output operations. This is the engine that really makes Spark run at blazing fast speeds, with an API that, like I said before, supports multiple languages, including Scala, Java, and Python. We also have Spark SQL, which is a component on top of the core, which has a relatively new data management solution called Schema RDB. And this is really geared towards SQL-based queries and analytics. Then we have the GraphX service, which allows Spark to process graphs, graph data, or even information that has been graphical in nature, thus enabling the easy analysis of graph data with a lot of precision. Stream processing is also a primary component of Spark, and allows it to stream large chunks of data with the help from the core. This allows you to ingest high-velocity data streams, so you can extract insights in real time for use cases such as IoT, which Lennox is going to be talking about later on. And last, but certainly not least, we have the machine learning library, or MLlib, which is a framework meant for structured machine learning. It's also predominantly faster in implementation than Hadoop. MLlib is also capable of solving several problems, such as statistical reading, data sampling, and premise testing, just to name a few. So what is Azure Databricks? In a nutshell, Azure Databricks is a fast, easy, and collaborative Apache Spark-based app analytics platform optimized for Azure. Azure Databricks is purpose-built to enhance your team's productivity, so you can start quickly by launching your new Spark environment with just a single click. You can also easily share your insights in powerful ways through rich integrations with tools such as Power BI, and improve collaboration amongst your analytics teams, your data scientists, your analysts, your engineers through a unified workspace. And it allows you to innovate much, much faster with these native integrations with the rest of the Azure platform that Deepsha mentioned earlier. Furthermore, Azure Databricks is built on the most compliant and trusted cloud, which allows you to simplify security and identity control with built-in integrations with Active Directory. It allows you to regulate access with fine-grained user permissions to Azure Databricks notebooks, clusters, jobs, and data. And last, build with confidence on the trusted cloud backed by unmatched Microsoft support, compliance, and SLAs. Last, but certainly not least, Azure Databricks allows you to operate at massive scale without limits and accelerate data processing with the fastest Spark engine. So with that, I'd like to introduce Prasad Chandravihar from Lennox International, who will speak to how they're able to harness the power of AI with Azure Databricks. Take it away, Prasad.
Thanks, Will, and good morning, everyone. So we'll be discussing about a specific use case which we solved with a combination of Azure and Databricks at Lennox International. So for the next 25, 30 minutes or so, this would be our agenda. So we'll go through a very high level what Lennox does and what are the problem statements we're trying to solve here. And this problem statement, just to give you guys a perspective, was not new. It was in the industry and with us for about a couple of years. So we were working on it even prior to using Databricks. So we'll talk about how we started and what are the challenges we had during that time. And why did we choose Azure Databricks on the first place, and how did the evaluation process go? What did we see standing out with Azure Databricks other than the other vendors compared to them? And how did we actually use Azure Databricks for machine learning, and what did we solve, and what were our results? And we'll quickly wrap up, and then we'll open up for Q&A. Okay. So about Lennox, I mean, Lennox is a leading provider of HVAC equipment, which means heating, ventilation, and air conditioning. We are a traditional business. We have been in the industry for about 120, 130 years. We have three core segments: residential heating, commercial, and refrigeration cooling. We are headquartered at Dallas, but we serve primarily North America. We do have business in Europe as well. So this is primarily a manufacturing firm, but we have a lot of our equipment do possess a lot of sensors, a lot of switches, etc. So this problem statement is about finding out a particular mechanical failure. I mean, there is one particular mechanical switch in one of our equipments which keeps failing based on different weather patterns, different conditions of runtime, etc., etc. Right? So the problem statement here is to find out when exactly does the equipment fail and what causes it to fail, so that we can have subsequent benefits towards it. I mean, there could be a quality use case coming out of it. There could be a predictive maintenance use case coming out of it. There could be engineering and warranty design issues which could be solved from that, right? So we have a lot of high velocity sensor data. So when I say high velocity sensor data, there are multiple sensors in the equipment. Each of the sensor data which we get is at a polling interval of about a minute. So we get data from each of our equipments every minute, so you can assume the volume of the data. I think for a year we had about billions of data sets collecting into our Azure cloud platforms, which we wanted to use and see if we can build any predictive models on top, understand that, correlate that with weather patterns outside, and understand the influencing variables. So that's what we were trying to solve at a very high level. So as I mentioned, I mean, this was not a problem which just started for us this year. This has been there for about 2 years or so. So we have been trying to solve this with various other tools, various desktop tools to be honest. We usually pick a sample of 15, 16 devices, see where the accuracy levels are. You can see some of the accuracy metrics which I've shown Not really great, but enough to tell us that, hey, there is meat in this data set. Some of the tools which we initially used were in the likes of RapidMiners, Alteryx. We had some people using SAS. We had some people using KNIME. So there was different groups of people doing different things. So that's how we started, with some low accuracies, not able to scale a lot because of some of the infrastructure limitations. And these are the three major challenges we had, right? So when we showed the engineering team, hey, we have some meat in this data set, hey, this is how we can proceed forward. One of the major concerns they have is, I mean, you're just doing something of 15 devices. How do we roll it out to the entire data set, right? I mean, to give you a perspective, we have about 25,000 devices in the field. So how do we scale it out? And that means we'll have to crunch through data sets of 10 billion rows in a single system, no sampling there. I mean, build a model on 10 billion data sets, build a prediction pipeline, and keep that going on and on, right? And also, as you all may acknowledge, doing such kind of an activity requires different types of skill sets, right? When I say different types of skill sets, you need data engineering pipelines, you need data scientists who are the secret sauce, but they are a combination of everything. And you also have data architects, you have platform engineers who are looking at production feasibilities, writing APIs around it and things of that nature. And you always need a cloud architect helping you figure out the right services, the right equipment, and things of that nature. Right, so that was another challenge, and I'll talk through what we did to come up through each of these challenges. And as the third one, as I mentioned in the last couple of slides, we have been using a lot of desktop type tools, and that was not helping us get anywhere. So what is the right cloud platform? I mean, you have multiple cloud platforms in the name of Azure, AWS, et cetera, GCP. So what is the right cloud platform? What are the right services among the right cloud platform? How do you get an environment where data scientists and engineers can collaborate, work towards one vision? So these were our high-level challenges, and I'll talk through each of them in detail to give you guys a perspective. So the first one where we said, hey, even collecting the data, right? So we had the very traditional Hadoop small file problem. So each minute when we get the file, or each day when we get the file from these devices, it is saved in each of these directories, like the screenshot you see on the right. So it ended up that we need to traverse through 7 million directory paths to gather the data, right? So Spark or Hadoop natively is not good with small files. I mean, they like a smaller number of files with larger data sets. These are large amount of files with small data sets, right? I mean, these are 1 KB files, basically. Each transaction, each log is a file. So Spark or Hadoop doesn't naturally like data sets like these. So traversing through, if we have to collect 10 billion rows into a table and do some analysis or even do some structured data sets, having that collected in one place was the biggest challenge, right? So we had to develop a batch program. We used Databricks to develop a batch program. It's basically a Python program which opens each file, reads that file, appends into a database, and goes to the next folder again and again, right? So that was a pain. I think until very recently, Databricks also released a product called Databricks Delta. I would urge you guys to look at that product as well. I mean, if we had the access to that product way before, I think this problem would have been solved. I think Databricks Delta solves a lot of these type of problems where you have small files orchestrating data from your data lake into a layer where you can do machine learning. Delta helps us a lot. But in this particular exercise, we had to go through developing a batch program in Python, code a lot, and then structure the data, right? So to get through this problem, it took us about several weeks to just solve this problem, get a big Parquet file which has 10 billion rows to even start the data set, right? So we spoke about the data sets, and I would like to quickly mention about the different varieties of data. So we spoke about the equipment level information which we get from the sensors and switches and things like that. We also used to get a lot of weather data from a third-party data source. We used to get a lot of demographic data sets. Now you can imagine it's 10 billion rows in one table. There are 7 other different tables, right? So combining that and getting the entire team working towards the same objective is definitely cumbersome. So, and as I mentioned, the getting a structure together, right? I mean, each of these verticals in most of the companies, small, medium, or large companies, I mean, you have vertical teams, right? You have a team focused on data engineering. You have a team focused on data science. You have a team focused on platform engineering. I think the paradigm which we shift was building a cross-functional team, which had all of these components. So we had, before we started this particular problem statement to scale out, we had the data engineers, we had the data scientists, we had platform engineers, and engineering SME who understands more about the equipment, can guide us, because statistics and machine learning can tell you till a point, and you need the actual functional expertise to go to make it actionable. I think that's where the engineering subject matter experts gave us a lot of thought, and also the big data cloud architecture, right? I mean, recommending the right platform, the right services at the right time, how not to overspend, keeping a check on all of that, guiding the entire team. So there was a cloud architecture team as well. And all of these team members, if you see the data engineering folks, helped us put in the right architecture, parsing JSON files into a standard structure, getting data from event hubs, structuring into blob, so things of that nature. Data scientists did some ETL work. They got the model ready for AI, right? When I say ETL, it's not the standard ETL, but feature engineering, feature extraction, things of that nature, and started exploring a lot of data science models. From a platform engineering, I mean, there was a guy who was with us with the data scientists and data engineering, always looking at, hey, what is the feasibility of productionizing this particular aspect? I mean, how do we wrap it up with an API at the end? And an SME, I mean, after every single model, I mean, I think where we think from a data science perspective that we are at a point, I think we got things validated from engineering SMEs. And I mean, somebody with the cloud architecture also helped. So this is the core team. And then we formed the core team, that was one. And then the third problem was talking about scale, right? I mean, when I say scale, how do we go from 15 devices to 25,000 devices? What happens if my data set is 1 million going to 10 billions tomorrow, right? So we needed something else other than the standard tool sets. We tried Azure's HD Insight, we tried Qbol, we tried Google's Dataproc, Dataflow, DataBeam, all of that suite of products. We tried Databricks, and then we did a lot of evaluations. And through this slide, I'll talk about the 3 key things about why we chose Databricks over others, right? So the first one is the problem which I mentioned in the previous slide, so collaboration, right? So looking at one platform, one notebook where data engineers and data scientists can collaborate together. So Databricks gave us that feel. It is basically Jupyter Notebooks plus a lot of other features on steroids, right? So it helped us collaborate. It helped us give the team a unified vision. A data scientist and a data engineer, irrespective of the location, could share one same notebook, go through the same code. I mean, data engineers could do something and then leave it off to a data scientist to do. There was a lot of collaboration from that. There is version controlling. You can comment, you can post it into VSTS, GitHub, and things of that nature. And also the point that we are a very lean team from a machine learning perspective at Lennox, and we didn't want a lot of resources focused on infrastructure work, right? I mean, you don't want a data engineer sitting with a data scientist every single time tuning Spark. We wanted an environment which should auto-tune or with minimal tuning. I think that's where Databricks actually shines, and Databricks are the inventors of Spark, so they exactly know how to tune Spark. And with minimal tuning is what I've mentioned, but I would say, I mean, we have not even touched a lot of the tuning aspects. We have found naturally that Databricks adapts and tunes based on the job we submit. It has been very intelligent in that particular aspect. And that has been another key reason why we went towards Databricks. So that eliminates a lot of admin infrastructure type work where, hey, I just go to my data engineer and say, hey, I'm trying to do a map side join, and then he tunes the executor memory, the Spark memory to that. So that was a big cumbersome, which we wanted to avoid and go past it, right? And also, there are certain jobs which require more memory, and you have certain jobs which do not require more memory. When you're looking at running a random forest versus a GBT, and GBT will require more resources. So things of that nature, we wanted something which can auto-scale, right? When I say auto-scale, and I'll show you in the demo as well, where we can set up some of those settings. So we can initialize with 10 different nodes, and you can ask it to scale till 150 nodes based on the job you do. That means that you're only paying for what you use. You're not firing up a standard cluster, which is 150 nodes, which is a big fat node, and then running it over and over again for one job, which needs more power than the others, right? So Databricks, we have seen it just auto scales in minutes. We are able to scale from 10 nodes to 100 nodes. Some of the models which we ran for this particular problem ranged anywhere from 2,000 cores to 2,200 cores, right? So that's the amount of compute which was given by the Databricks environment. In very easy, I mean, a data scientist could go into this particular platform and configure it through a GUI and then go forward with it, right? And also ability to start and stop. I mean, there is an auto terminate feature which I can show you during the demo as well. You can say, okay, after 30 minutes of inactivity, just kill the cluster. So that saves time, that saves money, resources, a lot of that, instead of having something like a standard traditional HDI which keeps running. If you forget to close it, then it's a problem from a cost perspective as well. And even when you're starting and stopping, we found out the average time is about 4 to 5 minutes. The cluster, even if it's about 10, 15 nodes, it is back up and running in about 4 to 5 minutes. And also some of the models, as you mentioned, I mean, as you can think, you would need multiple other components. I mean, we see Databricks as a platform which can give us access into H2O.ai, TensorFlow, Keras, AutoKeras, and things of that nature, right? So the ability of how we can integrate these services seamlessly on top of Databricks, that also played a very big role in our selection process. There is a GUI where you can go, and we'll cover this during the demo as well. We can go in and install libraries very easily. There is no bootstrapping required, no bootstrapping code. Everything can be done by a data scientist on a GUI. And the integration between H2O, TensorFlow, Databricks was very seamless. And also when you're doing problems of this scale or any machine learning problem, as you guys understand, the first step is to start with an exploratory data analysis, right? I mean, you would want to see what is the distribution of this particular variable, how many nulls, a lot of these. So instead of writing a lot of PySpark or SQL codes, we were able to successfully integrate Power BI, which is another Microsoft visualization product, on top of Azure Databricks. Databricks Premium plan offers a JDBC or an ODBC connector with which you can exactly connect Power BI, and then the Power BI can be in your desktop, it can be a cloud one. It just works perfectly fine. If you're trying to analyze the data, if you want to look at sales trends across months, if you want to look at number of nulls you have each month, so instead of writing a bunch of queries, I think we leverage the UI capabilities of Power BI to also connect directly into Databricks, fire up a Spark cluster. The same Spark cluster which was used for modeling was also used for Power BI. And so on and so forth. So we also found if we do something very big in Power BI, for example, I'm trying to group by and filter on something and do something. So that's a costly operation. Or if I'm trying to sort and display something, that's a costly operation. So we have naturally found that when we submit something like that to Power BI from a UI perspective, we have naturally seen Databricks from a backend also scaling out. So they are very, very tightly integrated. I can show you where we can go find those JDBC and ODBC connectors during the demo as well. But high level, these are the points why we chose Databricks over other competitors. And honestly, the expectation which we got from Databricks was way far away. far ahead than the other competitors. So we decided to start doing not just this use case, but multiple other use cases in Databricks. So in this particular use case, we spoke a lot about Databricks. Let's talk about the actual use case. So we mentioned that, hey, the device senses the data every single minute, right? So that data is sent to an Azure blob storage where you have equipment, weather, demographic information, a lot of that. We did not use the Azure Data Lake services. We used the blob storage for this particular exercise. And we had all the extract, load, transform pipelines, training the machine learning models, validation, scoring, building the entire pipeline, training it, scoring, etc. was done on Databricks. And I mean, you would have heard a lot of people say it, but it's actually true that it's going to be 70 to 80% of your time in a machine learning project is going to be structuring, preparing, feature engineering, feature extraction, creating labels. And I think in the industry, I've been speaking to a lot of people too, but we have not found a way to go past that at this point of time. So this is a painful process, but getting all of these equipment information together, weather information together, let's say this project spanned across 3 months, 2 months, or a little over 2 months was on data prep, trying to make sure, hey, we are not putting a lot of garbage in, cleaning the data, prepping the data in a way the models can be consumed. For example, XGBoost will need a different type of a preparation than random forest, right? So things of that nature. If you're looking at developing a deep learning algorithm or a neural networks, then all your variables needs to be standardized. So there are different types of prep, and I think that is a very iterative process from going from machine learning all the way into data engineering. That is going to be a cycle. And you would see when you're dealing with problems like these that you need both of you in the team working very closely together and then feeding inputs from one another. So that's how we saw. And then as I mentioned, I mean, majority of the time went through this particular pipeline, right? And then we are trying to predict, and when I said, hey, we are looking at predicting a particular mechanical switch failure, right? So we had a class imbalance problem. So when I say class imbalance, we had more scenarios in the data sets which had no errors or where it did not fail. And then you had, for every 590 million records, just as an example, right? So we only have 5,000 records which actually failed. So it's a very highly imbalanced problem. So we tried different approaches. We tried applying SMOT. SMOT is not available in Spark yet, so we had to work around it, a couple of things to get that. It's available in Python. And we tried undersampling the zeros. I mean, we tried reducing the number of zeros, which will still represent the whole population. So we had to implement a lot of smart sampling. And we also tried oversampling once. So there were multiple things which happened, but what worked out for us in this particular scenario was creating, hey, in this scenario of 500 million records, have the same 5,000 records each and every time, but take different sets of zeros, and you create different zeros and ones in training. We basically had about 5 or 6 different training sets where we did a lot of models on, and then we finally ensembled it. So that's kind of what worked for us in this particular use case. Again, data science is an art. It is not, hey, step by step do this, you get that. So what works for you in this particular use case. So again, we spoke about Ensemble. So what did we do? So we did a traditional random forest approach worked for this particular model, right? So you have a set of features which is feeding in on the top, you can see, and then you're building different. A random forest is nothing but an ensemble of decision trees. So we are basically building 100, 200 decision trees. We are collecting that as one different random forest. And each of these, applying random forest is not the big problem. I mean, understanding how it works and how it can be tuned, I think that was another challenge. So if you see the number of bins which has to be given as a hyperparameter, the number of trees which has to be given as a hyperparameter, the depth of the tree, the probability threshold. So all of this, I mean, we just ran an exhaustive grid search. And I think these are points which could have not been done if we don't have Databricks, because of the compute capabilities, we never worried about, hey, guessing what the hyperparameters could be. We were able to run an exhaustive grid search, actually get the one which had the best area under precision recall. So you can see a sample output of that. So each depth, each bin, what is the area under PR? So the area under PR kept improving. We picked the best of all of these parameters for each tree. And then finally ended up, we have different samples. I told you we have about 5 different samples of train. We ended up creating a random forest on each of that, and then we ensembled it, applied it on test data. So that's how we solved this particular problem. All of this was done in one single notebook in different languages, right? So in the team, we have different sectors of people working on R, for example, right? Because there are certain people in the team who have an academic background. I mean, R is what they like. So we needed a platform to help them build their R skills as well. There are other people who do Python, scikit-learn, things of that nature. There are other people who are very familiar to big data doing PySpark, and some of the models, as you know, something like XGBoost, it cannot be distributed in Python and Spark at this point. You need Scala to distribute it. So having one notebook where you can see from all the slides I've shown, right from the data collection where we had the small file problem, going until this level of building different random forests, creating an ensemble from that, was completely done in one single notebook with the help of Databricks. So again, that's what I mentioned. The language was PySpark. We use Python on Spark to get most of these things done. Each of the models were hyper-tuned. The reason why we went with ensemble model was that we had a problem of a lot of false positives because we have a lot of class imbalance in the data sets. It was predicting a lot of false positives, and we wanted to reduce it, and that is why we had 5 different data sets, which means 5 different samples of data. You're basically looking at the data 5 different ways, and we are saying, okay, only if all the 5 data sets or all the 5 models say it is a true, it is actually an error, or the equipment has failed. So that helped us reduce a lot of false positives from that aspect. Just to wrap up, this has been our journey. I mean, there was a journey even before we started the Databricks and then how we progressed forward. On the left, you can see accuracies, data volumes, tools, cloud service providers, what are the models we use, time to run a machine learning model. So this is the 15 devices is the place where, I mean, we were hanging ourselves between Alteryx and RabbitMiner and a lot of desktop tools. So you can see the accuracies, the recall, and true negatives which you get. We were processing about 2 million records. We basically built a decision tree algorithm, nothing fancy. Took us about 6 hours to run based on a lot of hardware limitations. We then started going towards 500 devices. We got better accuracies. And in the machine learning world, more data, the better, right? The idea of you sampling, finding a model, fitting it on bigger data sets, that's kind of vanishing right now. I mean, with the compute and the advancement of technologies you're looking at crunching the entire data set. So you can subsequently see, hey, it was able to run in like 30 minutes in the 25,000 devices, which used about 2,000 cores to run the model, but significantly lesser time. In about 15 minutes, we were able to collect the data sets, prep it, apply the right model, score it, test it, and then push it back. So this can also be done better, but I mean, at this point of time, it takes about 15 minutes to run the entire pipeline and thinking about a data set of about 10 billion rows, right? So that's kind of what we did from a use case perspective. I'll quickly jump into the demo. I just want to show you guys how the Databricks environment looks, and then we'll go from there. Okay, so this is the Databricks homepage. I mean, you can see on the left you have multiple tabs. This gives us visibility. So there is a folder for each person, so this is very organized. I can check into my folder, see the different notebooks I have. There are workspaces which can be set. There are data files which you can import. You can import a custom file. You can import it from a HDFS cluster, anything that should be fine. And this is where I think this is the point where we like the most, where you can select a cluster, right? I mean, it's currently stopped. I can just start it. It just takes about 3 to 4 minutes. You get the feasibility of selecting what type of, and it is a Spark environment, so you're going to have a driver type and a worker type. So what kind of drivers you want, what kind of workers you need. And this is the auto scaling which I spoke about earlier. So when you check this box saying enable auto scaling, and I say I want minimum to be 10 workers, and then it can scale up to 100, it is going to do that automatically based on the need of the job, right? And most of that, so you have different, you can see you have different families of processes which you can choose from. It gives you a lot of variety. All of this can be done from a UI perspective. No configurations which needs to happen at this particular time. You can schedule a job. You can just create a job from here. Let's say you have a notebook which has the entire pipeline. You just want to create a job which can be done from this particular aspect. I'm just going to show you one of the notebooks. So this is the collaboration which I was talking to you about. I'm just going to copy this again and then paste it in another tab. Okay, so you can see different sectors of people. I mean, you want to do SQL queries inside the same notebook. This is a PySpark query. This is a PySpark query again. This is a Python. This is using scikit-learn, etc. So all of this can be done in one single place, right? So that gives us a lot of benefits as such. And I just have a cluster up and running here. So if you look at, so this only comes with the premium plan. So if you look at this here, you have a JDBC and ODBC connector. You have the host name, the port, and things of that nature. And inside Power BI, you actually have a connector called as Spark. So this one. So this will help you connect. If you give those credentials which you see there, you can either import from that cluster or you can also direct query. When I say direct query, you can create a visualization here, not bring the data to your desktop or to your cloud, but still Spark is processing things on the back end, and it's super fast, right? So you can either do that as well. And there are several other, I mean, you'll be able to, when you log in for the community edition, I think all of this is available. You should be able to go through this as well. I'm just going to go back to the slides. Okay, so just to wrap up, I mean, you saw a quick glance of what we did at Lennox International from a use case perspective. Showed you a quick glance of how Databricks is, what we found interesting in Databricks. So just to wrap up, I think if you're looking to solve projects at this scale, I think you need a cross-functional team to execute it. I mean, data scientists, I know that's the secret sauce of everything, but you still need other components around it working towards the same goal. It cannot be in different vertical teams working in silos. It has to be a cross-functional team. And that will speed up the process a lot more, and that comes with some of the experience we have had over the last couple of years. And in most of the projects, I mean, it's not good for us to get demotivated. It's going to be 70% of the time is going to be spent on cleansing. Your data scientist will get frustrated in terms of they're doing a lot of ETL work, but that's the nature of the work as well. They will have to prep it, get it ready for the model. When you're changing models, the preparation has to be different. The way you look at it has to get different. And there is no secret sauce for if there is a model coming out at 50% as accuracy, right? I mean, you can't get it to 90, 95 just by doing a lot of statistics on top of it, right? I mean, tuning, stacking, ensembling will only get you 5-10%, but just give a lot of focus on engineering new features. The more you give to the model, the better it gets. So see how you can give the different varieties of the same feature, combination of features which you have. And that's where I think the H2 or driverless AI came into picture, because it was able to find out combination of variables for us, and we were able to feed in some of those combinations as well back into Spark, right? So that was another added advantage. And H2 has two different products. I mean, they have driverless AI, which is for engineering features, for automated machine learning, and they also have sparkling water, which is basically H2O on Spark. They have the same set of algorithms. I wouldn't lie saying they have a different set of algorithms altogether, because if it's GBM or H2O, or random forest, I mean, these are algorithms which have been built 50, 60 years back, but their implementation of that algorithm is impressive. It's faster on bigger data sets, and it is also, there are some models where you can auto-tune, auto-ensemble, and things like that. So I would urge you to explore that option. If you're using Spark right now, if you're comfortable with Python, I think H2O on Databricks, H2O on Spark, which is sparkling water, makes a lot of sense as well. And then you always need a platform. I think right now, I personally don't see a lot of tools which can do the collaboration and develop the project end to end. It's just Databricks just gave us a platform where you can reach out to different products like TensorFlow, Keras, etc. So having a platform like that for your team is also very important to execute projects at that scale. So these are just my thoughts, and then I think that's all I had from for today's presentation. I'll give it back to you, Will.
Hey, Prasad, Deepsha, Wayne, thank you for that excellent presentation. While we get ready for our QA, I'm going to briefly leave up this screen where you can find some more information about Azure Databricks. But I want to thank the audience for their participation, because we've had a lot of questions that have come in during this presentation, and we'll do our best to get through all of them in the time remaining. So during our QA, I'm going to leave up this screen with contact information for Prasad and Deepsha if you'd like to contact them following today's event. So let's get started. Prasad, you talked a lot about obviously Databricks and H2O AI and that sort of thing. Were there any other technologies that were in this project that we should be aware of that were important?
Sure, Bill. So in this particular project, I think the majority of it revolved around Databricks, but from a storage aspect, we had different data sets, right? The equipment, the gather, etc. So it came from a blob storage. We had a couple of other tables in Oracle. So the data storage and the tools used there were a bit more different. And obviously, Databricks was the backbone. We also used Power BI on the front on this particular project. We have refrained from using a lot of Jupyter notebooks or desktop tools, and especially for this particular problem of this particular scale, I think it has to be done all in cloud in an environment like Databricks.
Well, thank you for that clarification. This was really a fascinating use case about, I guess you would call it, I would call it preventive maintenance. But the audience has asked, would you please summarize what was the business value of this for you? I saw some very good accuracy scores there. What happened with the model after you were done?
So the accuracies translate into the business value, you are right, but I will not be able to exactly give you a number or tell you the exact business value, but high level, I think we were able to work with our engineers a lot more to get some of the designs right and help on understanding preventive maintenance, right? Help on predicting when an equipment will fail. What are the conditions which leads to an equipment which gets failed more often than not? These were inputs which the engineering team wanted so that they can do a lot of quality analysis and things of that nature from a design aspect. So that was in short what happened after this. We were able to, from the Ensemble model, we were able to take out, hey, these are the parameters, these are the thresholds, especially if the weather is this much and the pressure is this much, this is where it fails. Now the engineers did a lot of stress testing on it and see how we can come across it. So a lot on the design and quality aspects, high level, Bill.
Oh, fascinating. Really, a really interesting project. One of our audience members asks, since we've been talking about a streaming application, and I think a lot of us associate Spark 2.0 with streaming, would you use this same architecture for a non-streaming project? A lot of our clients, or presumably your clients, don't have streaming problems. Would you use this same Databricks and Azure setup for classical static machine learning?
Yeah, I can take that, but I think we can use it. So at Lennox, what we're doing is we have Databricks as the unified platform for machine learning. So if it's not streaming, it's just pointing to a blob store. It's basically, you can also enable your VNet peering back from Azure into your data center. You can use Databricks to hook it up to your traditional BW data sources or Oracle data sources, and even if you don't need Spark, for example, right? So we are at Lennox, we're doing some use cases where, it's static data, it's smaller in size, it's in millions. You don't want Spark maybe an overkill at that point of time. And also using regular Python or single node Python might help. So in that case, we just put a big fat driver node. We don't put any worker nodes. And then your whole Databricks environment starts behaving like a simple Jupyter notebook. So we do Databricks for both small and big data sets, but we have different clusters, different configurations, and we use different languages as well. For more static, more smaller data sets, we would go with Python scikit-learn, which is a bit more easier. And then for larger data sets, we would have PySpark, and we have different buckets of how we can get there.
Oh, that's very interesting.
I want to add some more scenarios to that. There is like very industry-wide scenarios that you can do with Azure Databricks as well, like just fraud detection, medical diagnostics, customer churn. In fact, one of the most common use cases that we see is, like Prasad pointed out, just bringing your traditional data sources together into a single hub for your visualization needs. So just a very, very basic example, if you don't want to do predictive maintenance or predictive learning, you can just use it to convert unstructured data to structured data so that you're able to take advantage of all the data that exists in your organization.
Well, thank you. And Deepsha, while we're on the topic of Azure as opposed to Databricks, there's a question from the audience as to whether or not Azure would be good for beginners in machine learning. And then, Prasad, maybe you could comment also on that same question for Databricks.
Sorry, can you repeat that question, Bill?
Would Azure be a good tool for beginners in machine learning?
Well, absolutely. So Azure provides you that end-to-end tool where if you want to just start your tool with bringing the data together, Azure Data Factory has a user interface that doesn't require much coding. So you can just absolutely, as a beginner, start to bring your data sources together. And within Azure Databricks, the good part about that is it supports multiple languages. So whether you're comfortable with SQL or Python or R or Scala, and especially for beginners, a simple querying language like SQL, if you want to use that to start your machine learning, you're absolutely free to start using that to bring the data together.
Terrific. Prasad, anything to add?
No, I completely agree with it. I mean, if you've been in the industry for about a year or two, you would have a strong language, whether it be SQL, Python, anything, right? So you just need that base, and you should be good to go and get started. Even though there is a lot of codes, it's not that hard to pick it up. So even from our team's perspective, using Databricks, we just started using it this January, and we did not have a big learning curve. We were able to complete a project at this scale in about 2 to 3 months, learning Databricks and Azure environment and things of that nature. So I would strongly believe it should be easier to start with.
That's
well, thank
awesome.
You.
And another thing that adds to the ease of use with Azure Databricks is that with Spark, usually if you start Spark, it's complex to bring together and start using. But with Azure Databricks, so Spark is completely managed, which means that you can just spin up clusters much more easily as a beginner. You don't have to manage that. Azure Databricks does the managing of Spark clusters behind the scenes for you.
Well, thank you. Thanks for that clarification. Now, Prasad, you described using Python and PySpark in your project, but Deepsha, you just mentioned the ability of Azure to deal with R, and we have a question from the audience that kind of splits the difference because it's about the H2O app that you used, and the audience member says they're having trouble getting H2O to run in an R environment. I'm not sure that you would have any insight into that, but do you have anything to offer on that?
I can take that. So very recently, with Azure Databricks, we announced that if you're comfortable using R, but you want to take advantage of the big data capabilities that Azure Databricks provides, you can actually run RStudio within Azure Databricks. So you'd be comfortable with the same environment and you want to bring that to Azure Databricks while taking advantage of the Spark backend. So check that out, and that should definitely help you take advantage of the H2O capabilities with R. Prasad, do you want to add anything?
So in this particular project, we basically use Python, but as I mentioned, there is a different domain of people using R as well. So instead of even going at the RStudio level, which is, I think that's a great thing to have, we are also trying that out in Lennox right now, looking at hooking up RStudio to Databricks. We were also able to use the regular Spark R, the distributed R on H2O. I'm not really sure what is the exact problem that audience is facing, but I think from a Lennox perspective, we were able to make that work using Spark R and H2O as well. So that's definitely possible.
Terrific. Well, thank you both for that answer. Now, Prasad, a good, solid data science question that also interested me. You said that you tried 3 different approaches in resolving the big class imbalance that you had in that data set. Which one worked the best?
So the last one, the third one, which I said, hey, we had about, for example, we have about 590 million records, out of which only 5,000 of them are erroring out, right? So those are your ones, those are your target which you're trying to predict. So we basically created 5 different samples built from the same data set. So you had the same amount of ones in each of the sample, and then you had different samples of zeros everywhere. So we took, hey, let's say the first training data set has 100,000 rows, right? It has 50,000 zeros, it has 50,000 ones, and it has one set of 50,000 of zeros. The next sample, it has the same set of 50,000 of ones, but the way we selected the zeros in the second sample was completely different. We had a different seed, we used a different sampling technique. So that way we created 5 different facets of training data. It was not one training data and testing on one test data. It was 5 different training data sets where we ensembled it to fit it on test. So that model worked for us in this particular problem.
Oh, fun. Okay, thanks for that answer. Some technical questions about the platform, platforms, I guess I should say. And this audience member asked, does Azure Databricks provide VM instances with GPUs for TensorFlow Keras and deep learning frameworks already installed?
So Azure Databricks support has a specific runtime for machine learning that has the deep learning frameworks and packages pre-installed and pre-configured. So that specific runtime is called Runtime for Machine Learning. It has packages from TensorFlow, Keras, XGBoost installed already, and it also has support for Horowatch. That also, in fact, supports the GPU VMs that are ideal for deep learning scenarios.
Oh, terrific. Oh, well, thank you for that clarification. Now, Prasad, I know that in your project you already mentioned that you used the Delta feature, and this audience member has asked, does Databricks support Delta? Well, clearly it does, but they also mentioned ML Flow. Do you know if that's supported currently, or is that something for the future?
It is. I mean, Databricks are the creators of ML Flow, or that open source platform. So in our current architecture, we do have MLflow implemented inside Databricks. And from a data science community, keeping track of what you have done over and over again. I mean, let's say I'm trying out a model which is depth 5 and what iteration I got. You might run into hundreds of iterations. So MLflow does a good job of tracking it, and it has an easy integration. I think when you go to the Databricks portal, when you select the Databricks, the version, I think they have it from 3.6 to 4.3 or something. Anything above 4.2 will mention that, hey, this is with MLflow. So that comes along with MLflow as the Databricks package itself.
Well, that's terrific, and I was very impressed by that Delta application feature and your ability to handle so many small data sets. Were you dealing with both streaming real time as well as static batch data?
So not at this point. I mean, in this particular, just to clarify, Bill, so in this particular use case, we did not use Delta. I mentioned that it will be a good use case for Delta. But after this, I think we have done a couple of other use cases where we have ingested both streaming and static data sets using Delta. And that was a good one from our perspective as well. So it works good for, say, you have historical data sets in an ADLS environment. You have multiple small files. You just want it is static. It's not growing more. I mean, you just want to ingest it. We have tried that, It works perfectly fine. We have tried hooking up Delta directly into the event hubs, and it is able to, with very minimal, I think we tried Delta with about 2-3 nodes, and it was able to ingest about 10 million records an hour easily. So both scenarios, I think we have tried that out and works great well.
Hey, Prasad, Deepsha, thank you for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Prasad and Deepsha and the Databricks team so they can follow up with you after today's webinar. I have just a few quick announcements. If you'd please mark your calendars for September 5th, that's our next DSC webinar, Getting Data Down to a Science, Code-Free and Code-Friendly Machine Learning. Also, remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Databricks for their sponsorship, and particularly our speakers, Prasad Chandravihar, Deepsha Mengani, and Wayne Chan, for their insight into today's topic. So this is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on September 5th. Have a great day.